Hi everybody, this is Mrs. Hayes and this is video note 6.3, Transforming Parabolas Notes. Remember from Unit 2, if you wanted to look back in your packets you could, the ways we already discussed how a function can be transformed. It can go up or down, left or right, wider or narrower, and reflect over the x-axis. You might want to think back to the absolute value of x function and how a negative in front would make it be upside down, and how the 2 in front changed the slope of these lines so it would get steeper, and how a 2 inside with a minus would make it go 2 to the right, and how a 2 outside with a plus would make it go up 2. That's a quick little remember this kind of thing, but we're going to look at vertex form for parabolas, and that obviously is going to have a square in there. That's because it's a parabola or a quadratic. You're going to have a positive or negative in the front with the a value. That's going to make it be reflected, narrower, wider. You're going to have a number inside that's going to be moving it left or right. If it's a minus, it's right. If it's a plus, it'll go left. It's the opposite of what you would think. And then a k on the outside. So if you had like a +6 out here, it would go up 6. So it looks confusing until we put some numbers in. So let's look at these transformations and vertex form a little bit closer. In exercise 1, it says determine the transformations of each parabola compared to the parent function x squared. So we're picturing this parent graph centered at 0, 0 with his vertex. Now if we move him by putting a negative in the front, the negative is going to reflect it over the x-axis. Reflect over x-axis. The 1/2 is going to make it be wider. I always think of it as like a slope. If your slope was 1/2, you'd be going up and over, up and over. So you'd be stretching this wider, sort of like slope. The x squared is part of the equation. There's the parent function. And then -8 is going to make it move down 8. Now, being that we called this vertex form, you might want to picture this real quick with a 0 in the square part and a -8, because the vertex is at 0, -8. Just something to keep in mind. For the next one, we have the negative first, and that's going to make it reflect over the x-axis. Oh, wait a minute. I didn't show you that. That would make this whole thing be upside down that I was picturing, right? So reflect over the x-axis. I do have a way of remembering that. When there's a negative in front, it'll be like a Mad Max, maximum, looking mad. If you slant his eyes, he looks a little madder. If there's a positive in front, I call her Pretty Minnie. She has a minimum, and she's a little prettier than Mad Max. So if there's a positive in front, it won't reflect. If there's a negative, it reflects over the x-axis. If there's a 2 in with the x, so our little positive 2 in with the x, is going to make the graph go left 2 units. And the -1 at the end, outside, not in with the x, is going to make the graph go down 1 unit. By the way, the vertex here would be at -2, -1. You can see that with those numbers right there. Letter C, the 3 is a number bigger than 1. 3 is bigger than 1. Graph's going to get steeper. And what's going to happen is that means it's getting narrower. So it's going to get like steeper, narrower, as opposed to the parent graph that might look like the green one there. Okay, then we have a 5 inside with a minus. So the -5 inside is going to make it go right 5, right 5. And we have a 6 on the outside, and that's going to make it go up 6. I don't know if you know where the vertex is. I might ask this in an upcoming question. The vertex would be at positive 5, positive 6. You always change the sign on the x. And exercise 2, the original function. Where the heck did exercise 2 just go? Here's the original function. We're going to shift it to the right 5. And it wants to make a function g of x and write its equation. So I'm going to call g of x. It's still going to be the same type of function. It's still going to have a square on it. The plus 7's not going to change. But if we go right 5 in with the x instead of just x squared, I'm going to have to put a minus 5. There's our new function. Picture that. Determine the vertex of the parabola. Vertex of the parabola. So I'm going to look over here. I see it. Let me count it out. I believe the scale is 1, 2, 3. 1, 2, 3, 4. So I think it's at 3, 4. There's my vertex. Vertex 3, 4. Is this a maximum or a minimum? Well, if it was a maximum, it would be like this. If it's a minimum, it would be like this. You can tell that this is a high point, and that makes me think it's a maximum. Next page. Exercise 4, determine the vertex of each parabola below, and then determine if it's a maximum or a minimum. So the vertex has to do with shifting the graph away from that original vertex of 0, 0. We're going to shift it 8 to the right and 5 up. So it'll be at 8, 5. Change the sign, don't change the sign. Is it a maximum or a minimum? Out front, I see a positive. That makes me think minimum. Remember, pretty mini, pretty mini. Minimum. Okay, part B, I see a 1/5 here, but I don't see a negative, right? So if it's positive out there, it's going to, again, be a minimum. And that minimum will be at, change the sign, -1, down 4, -4. Exercise 5, first identify the vertex. Vertex, 1, 2, 1, 2, 3, 4, 5, 2, 5. Write an equation in vertex form. All right, f of x equals, I could have said y equals. Let's see, there's going to be a square. There's going to be an x. Change the sign on the 2, -2. Put the 5 on the outside, and it's a +5. And lastly, state the range. The range, if you remember, is the y values. So all the y values fall from this highest point down to -infinity. So you could say the highest point is 5, right? That's the maximum value. So you could say y is less than or equal to 5. If you write that in interval notation, that would start low at -infinity and go high to 5, and it goes all the way. Notice I included, closed circle, equal to sign, included, closed circle, bracket. That's the range. And then exercise says write the quadratic in vertex form. So that means complete the square and state the vertex. So f of x equals x squared plus 8x plus blank plus 11. And by the way, you're going to have to take off a number. So the number that goes in the blank, let's see, x and x. Trying to make this perfect square trinomial. Split the 8 in half, 4 and 4. It was positive. This was from last unit. If you don't remember, come ask me. I multiplied 4 times 4 and got my 16, taking a 16 away. So I have f of x equals x plus 4 squared minus 5, because this is -5. That's the equation, and it said, tell me what the vertex is. So the vertex will be, change the sign on the 4, and -5. Notice that if it tells you to write the quadratic in vertex form, that means complete the square, so that you can see it. This was standard form originally, and this is vertex form. Next question says, write this equation that's in vertex form in standard form. Show your work algebraically. So I'm going to take this negative t plus 3 squared minus 11, and I am going to square this out. T plus 3 minus 11. To me, that means go to the box method, but some of you might be able to do this in your head. T squared, 3t, and 9, 6t. So this is a negative in front of all of this. I need parentheses. T squared plus 6t plus 9 minus 11. It's not in standard form yet. I need to distribute my negative. Negative t squared minus 6t minus 9 changes all the signs, minus 11. And the last step is negative t squared minus 6t minus 20, because I got like terms to combine. And remember that that was h of t equals. And that's standard form, highest power, power of 1, no power. Thank you for joining me.